So we have a picture here from a mangrove forest, and we can see that we have the area roots coming up here. And the question is, explain why mangroves that are submerged underwater for a large period of time have aerial roots. And what we need to think about here is, well, the roots are metabolically active and they need energy. They don't get anything from photosynthesis. To do that, they perform respiration. And the mud in this area here, they can become hypoxic or even anoxic, so there's no oxygen down there. So aerial roots allow the roots access to oxygen for respiration from the atmosphere. This is about as clear as I think you can be to get all 3 points. So we're told that a student noticed at low tide, area of sediments around the area roots seem to contain more water compared to sediments from the lower shore. We are asked to describe an investigation the student could safely carry out to compare the moisture content of sediment from the areas with area roots with the moisture content of sediment from the lower shore. This one is 100% the same as practical task 5.5. So if you have read that part, you're good to go. Otherwise, well, there's a lot of points on the line here. 6 points. So I'm going to try to show how I would do it. I would start by saying you could set up a system of quadrants to do random sampling of a sediment from both areas. And I will collect the same volume, it's important, of sediments from each sample site. I would collect them at the same time of the day with the same tidal conditions. And I will repeat this process in other quadrants. Then I'll take the samples home to the lab and determine the mass, and here you can say with the scale to be more accurate. Then I will heat the sample gently until the weight no longer changes, and then I'll determine the new mass. Here again you could write with a scale. I could use a difference in mass before and after heating to calculate percentage of water lost. Then I can see how much more water there is in one sample than the other. And when always you have one of these here, you can always get a point for, well, you have to use appropriate safety conditions, precautions, sampling the sample. So in the case of mangrove here, having rubber boots on and knowing the weather forecast, having a life jacket, and in the lab, using appropriate safety precautions, you're heating something, so avoid touching hot samples, and use eye protections wherever appropriate. So last question, figure 6.1 shows some kelp, and we're asked here to state the kingdom of kelp. And the mistake I saw many right here was, yeah, kelp, it's a plant. It's not a plant. We are in the proto kingdom here because kelp is a macroalgae. And this one here, if you want to look in the book, is section 3.5 in the book where you find the data here about kelp. So our next question goes into theory from section 3.5. And this is an explain question. Explain how 2 features of the kelp enables it to maximize the rate of photosynthesis. So it's not enough just to mention the features, but also you have to explain how they do it. It's a 4-point question. So you say that it has large and flat blades. Okay, that's a feature. And then I'll say that the blades have a large surface area for high light absorption and carbon dioxide absorption to power photosynthesis. You can also say the kelp have chloroplasts containing chlorophyll to absorb light and carbon dioxide to do photosynthesis. And the one most of my students remembered was the kelp has gas bladders to hold it closer to the surface. That's the feature. So light intensity is higher and will result in a higher rate of photosynthesis. Okay, so we are now looking at a food chain where we see a change in biomass from each trophic level. But the first question they ask about is our wonderful sea otters. And if you're not a fan of sea otters, well, do you even study marine science? Because they are cute and awesome. And they ask, state one characteristic feature that is used to classify marine organs of mammals, and the easiest one here would be fur. But you can also talk about lactation. Okay, then we are asked to calculate the percentage of biomass present in the kelp that is transferred, like from the kelp here, that is transferred to the sea otter. In this case here, we have the difference is we have our 0.052 here in the sea otter, and we have our 5,000 here. But since we want it in percentage, we multiply by 100, which gives us 1.04%. As we can see, there is energy loss between the kelp and the sea otter, so we lose about 90% on each step. This is the classical 10% rule. And they ask us to suggest reasons for the loss of biomass, and some of these answers here you can use whenever this question comes along. So I'll say that not all organisms are eaten in the food chain. Some of them might move, although they're not the most migratory species here. More important is energy is lost in respiration. The kelp also respirates at night, and our sea urchins, they respirate. Energy is lost in movement, although again, these are not the most active species. Some part of the organisms eaten might not be digestible, so that energy will then be lost as feces and marine snow. And some sea urchins can be harvested by humans, and thereby they are removed from the food chain. And the last one here, the student reads, the kelp does not store its energy as starch. Describe how a test to sample the kelp to show if starch is present. And here we go back to our food tests. And here simply you just have to remember the iodine test. You add iodine, note the color change. If starch is present, the iodine will change from brown to black.